which brings us on to some suspicious structures. I'm not going to go through all of these by any means, but maybe highlight a few of them. Materializing views or inline subqueries. Well, we saw an example of that earlier. And here's the execution plan I pulled off before. Oh, no, not that one. I want the one I've got here. Yes, whenever you see the view keyword as an operation, that means Oracle had to stop what it was doing and do that. So to construct the view GSP service, it had to stop all of the processing while it scanned that, did a hash join to that, removed the duplicates, and came up with that. Materializing views is sometimes good, sometimes bad. Generally speaking, if Oracle did it of its own accord, it's good. If it was forced to do it because of a programmer's structure, it's probably bad. But that's only very general statements. It's something you've got to watch for. Right. Filters applied to tables after access through indexes. That's an interesting one. The way it looks in an execution plan, take a statement like this. Select star from emp. Well, hire date equals 2 dates and job equals Clark. So I'm using the same data sets all the time. And look at the plan. Index range scan. Access, hire date equals that. Good. We're getting index access. And Oracle expected to get 2 rows back. But the immediately following operation, table access by index row ID, we're searching that to get some index keys, to get some row IDs, then we're retrieving the rows and we're applying a filter. The filter, job equals Clark. So what's happened? Well, we've retrieved 2 rows and then we've thrown away one of them. Again, multiply it up to the real world. You might be retrieving 10,000 rows and discarding 9,000 of them. Filters are waste. We're retrieving rows that we don't want. And whenever you see this sort of structure, one operation with an access method and the next operation with a filter, think to yourself, surely there's a better alternative than retrieving a bunch of rows, looking in them, and chucking away half of them. That's what I mean when I say look for filters applied to tables after access through indexes. The solution here, one solution, compound index. Of course, if my index were on hire date and job, the access method would have got us the row we want, and no need to filter later. Also related to filters, filters that discard a lot of rows very close to it. If you're retrieving a bunch of rows, inspecting them and throwing them away, clearly there's something wrong. Filters applied late in the plan. You want to cut down the number of rows as early as possible in the execution plan. You don't want vast numbers of rows flowing up through the plan and only filtered out at the very end. Repeated access to the same objects. We see that here in this execution plan. Again and again, we're hitting the same objects. Very suspicious. Possibly something wrong. Aggregations that reduce the cardinality. Aggregations that, don't reduce the cardinality. That's another of my pet hates. Unnecessary aggregations. In this case here, we see that hash join has returned 6763 rows. Sort unique, there's still 6763. Same thing here. That one has actually reduced a few. 56,000 rows reduced to 45. In this case, 673, none thrown away. This one, hash joins actually reduced a few. This one, the hash joins returned 64,022, sort unique, still 64,022. Always look for this sort of thing, where Oracle has had to do a lot of work to remove duplicates, and there weren't any. Watch for that. Aggregations that are unnecessary. Almost certainly, he's got a distinct in there, but the nature of the data is the fact there can be no duplicates. Understand your data and think, do we need that aggregation? If you really do need the aggregation, and in this one it looks as though you do, the aggregation is removing some rows, Perhaps you could handle the duplicates further in the query. Get rid of them later on, maybe, rather than going to sort unique, which is suppressing the merging of the view. Look-through aggregations, are they necessary? Same thing with outer joins. Very often I see outer joins thrown into queries where they don't generate rows. You're outer joining to a table, but there are no rows generated by the outer join. Possibly use of constraints would mean that Oracle would then realize the outer join can't possibly generate more rows. So wherever you see an outer join, maybe you need it. And if you need the outer join, you need the outer join. Very frequently, I see outer joins that aren't actually needed at all. But we talked about some issues with null already. Internal function call, that's often to do with implicit typecasting. Maybe it's a good thing, but maybe Oracle's being forced to do it for some reason. Correlated subqueries, repeated execution of the same queries. Oracle will do its best to get rid of correlated subqueries, but it can't always do that.